Hello Internet, there is a lot of misinformation about how GPS really works, so I want to clear up some of it. I'm going to explain why GPS uses 4 satellites instead of 3, and why Einstein's theory of relativity does not matter after all. This will be technical and there will be some math involved.
There are currently 31 GPS satellites in orbit, and they are placed so that the GPS receiver can always find at least 4 of them. Each satellite has on board an atomic clock, which is precisely synchronized with the clocks of all other satellites. Their clocks are updated daily from Earth. Each satellite continuously broadcasts its time as well as the position of the satellite itself. Your receiver calculates the distance to each satellite by taking the time of the receiver itself and subtracting the time broadcast by the satellite, multiplied by the speed of light. After doing this with 4 satellites through a process called trilateration, your GPS coordinates are calculated accurate to within 8 meters or less. Because light can travel 8 meters in under a millionth of a second, all clocks must be accurate to at least within a millionth of a second. The satellites are synchronized within this precision, but the clock on your GPS receiver is not. How then can the position still be calculated if your receiver doesn't know the true time? First, we need to understand how trilateration works. As we shall see, technically only 3 satellites should be required. So why do we need 4? Here is satellite A. Using this formula, we calculate our distance to it. This places us on the surface of a sphere with radius equal to the distance calculated. Here is satellite B with its own sphere, which overlaps the first. Knowing that we are on the surface of both spheres, we also know that we are at their intersection, which is in the shape of a ring. I'm going to erase this and draw the ring from the side. Here is satellite C with another sphere. Its sphere intersects the ring at 2 points. We therefore know that we are at one of these 2 points. Now you may be thinking to yourself, aha, you do need 4 satellites, because with 3 satellites there are still 2 possible coordinates. Normally you would be right, but here is the Earth. One of those 2 points will be somewhere on the surface of the Earth, but the other point will always be up in space somewhere. And I for one know that I am not in space. Why then do we need 4 satellites? Remember that the clock on your GPS receiver is not accurate to within a millionth of a second, and so the coordinates provided by 3 satellites cannot be trusted. If you don't believe me, try this experiment.
So the only thing you'll need for this experiment is a phone that has GPS on it. Currently the time on my phone is 1:31. What you will do is change the time on your phone by 10 minutes. There, so now the time on my phone is 1:41, and then you will go to your GPS and pull it up and see if it still works. And there it told me where I am.
There are 600 seconds and 10 minutes, so if we multiply 600 by the speed of light, we will find that your calculated position could be off by as much as 180 million kilometers. That is not accurate enough to even tell you which planet you are on, but if you do the experiment, you will find that your GPS still works. The secret is having 4 satellites. I won't go into how this works, but with 4 satellites we have enough information to calculate exactly how far off your clock is. Your 10 minutes of error can then be compensated for, and your GPS will be just as accurate as ever. Now what does this have to do with Einstein's relativity? According to relativity, the clock of an orbiting satellite will run faster by 38 microseconds per day, which we are told would result in a GPS error of 11 kilometers. The GPS clocks are therefore adjusted by this amount daily. They are also reset daily to ensure that they are always synchronized with true Earth time. The problem is that this error of 11 kilometers assumes that the clock on your GPS receiver knows what true time is, and as we have just demonstrated in our experiment, it does not. Your receiver depends on the clocks of the 4 satellites. Because of how the coordinates are calculated with 4 satellites, the error of 38 microseconds is already accounted for. In fact, we were able to account for an error of 10 minutes. All that matters is that the satellites remain synchronized with each other and not with the Earth. GPS therefore does not validate relativity. For more information, see the links below.